And then we come to insects, which are the best organisms. And for the rest of the lecture, I'm going to talk a little bit about some of the insects that we won't meet when we talk about social insects, because they're interesting too, and they're some of my favourite things to study. They have a massive, massive diversity of social lives, but not all of them are as complex as a bee, an ant, or a wasp. And I just want to take you through some of the things you can find. You have lots of parental care in insects. You wouldn't think that insects are things which would do parental care. You don't think of them as kind of loving their offspring or anything that you might attribute to a vertebrate. But parental care can be done by the male. This is a male giant water bug carrying his eggs on his back, and he does push-ups in the water to oxygenate his eggs. You have lots of care done by the female. That is a shield bug guarding her offspring, and she'll guard them all the way up until adulthood in some cases. And then in some cases, male and female work together to bring up their offspring. And this is a burying beetle that collectively have a delightful life cycle where they find a dead mouse or rat or something, and then they bury it in the ground and they chew it up into a ball of meat, and then they lay eggs in it, and they will spend the rest of the offspring development chewing up the meat and physically feeding it in a progressive way to their larvae. And there's a lot of work done on burying beetles, how the larvae communicate with the parents, telling them that they're hungry. There's video footage of larvae basically begging to the parents, saying, "Give me some food." The social dynamics of life in burying beetles is extremely interesting. If you take insect biology, next term we will have a whole lecture, a whole seminar from one of my friends who works on these things long term, and we'll delve into the social lives of burying beetles. You have other insects that have extended family lives. There are these deadwood beetles that live in some of us found, I don't know if anyone from Brazil remembers finding the deadwood beetle underneath a stingless bee colony. They can get quite big, but they live in kind of galleries with males, and with the male and the female, and adult offspring from the previous generation, which all help to feed offspring, and then the larvae. And they call to each other through the wood. They kind of produce little kind of stridulating calls, which provide information about where they are and how hungry they are. And these are some more thrips. These ones are from South America. They have males and females, and they live in communal bivouacs with their offspring. Wood roaches have the same kind of thing. Wood roaches have a family life which is, again, similar to the deadwood beetles, a male and a female, several adult offspring, and then the next generation, all within dead wood. And they form the evolutionary ancestor to termites. Termites are effectively just social cockroaches. You have these weird things called web spinners, which live entirely under silk. They've got these great organs for making silk that they just kind of, a bit like a window cleaner, they'll kind of wave it around, but they're laying down silk all at the same time, and it's a fascinating thing to watch. But they live in silken galleries along with their two parents and a bunch of different offspring. You have cooperation among larvae. This is a video. I included this video because last year in Brazil we saw these on the forest floor, kind of larvae of a sawfly which form a migrating slug, which kind of basically keeps them safe from predators, because predators won't attack that. They are very nasty. They're kind of poisonous. They've got irritating hairs, and that slug is something which will deter predators as opposed to them being vulnerable on their own. And the adult just looks like any old kind of wasp, although it's got quite cool antennae. You've got tent caterpillars, butterfly larvae, that form collective webs which thermoregulate. They put them in places that get the morning sun, and the sun will shine into this kind of cube-shaped web and heat up the middle of the web such that they get the benefit of the heat. They will live in this for a few days and then migrate to another place and build a whole new tent. You have the thrips I was talking about. for example. So these kind of simple family lives, we've talked enough about thrips. You've got very simple ant societies where females will cooperate, a bit like in the thrips. Females will cooperate in order to establish new nests. Many, many properly social ants, their lives begin, their nests begin with females cooperating initially to form a nest, because it's very competitive for nest sites between groups, and it takes a group to cooperate and establish a nest. But then as soon as the nest is established, they'll fight to their death, and the surviving one becomes the queen. And in some ants, you get groups of females sticking together without fighting to the death, but one of them becomes the queen and the others subordinate themselves to them. Again, so they become subordinates and they become altruistic. So the dominant one becomes what we call the gamagate. And this applies to those, like in Brazil I was quite actively looking for these giant ants that we found in the previous site. This is them. They're kind of like 7 or 8 centimetre long ants that you get singly on the forest floor. And they form kind of loose aggregations of females, one of which kind of is behaviourally dominant to the rest and produces all of the offspring. So all the workers are potentially reproductive, but they kind of decide to be. They're called queenless ants, and you can read about them in this book. This incidentally, is a book which is all about these primitively social insects, which is a fascinating read if you find it. I've got a copy if anyone wants to look at it. So we're going to wrap this up soon, but how do we make sense of all of this variation? We've got tons and tons of different social structures, tons of ways that altruism is expressed in societies, and lots of people have decided to slice this up in different ways. And we'll meet some of the different ways in the subsequent lectures when we consider the more famously studied social societies. But one way is according to the specialization of castes. And this Crespi and Yanega paper, we're going to revisit that when we come to talk about eusociality. But they suggested that it's the presence of castes which defines a society. So you've got the two questions you ask are there helpers which provide parental care? And are there castes? Are there kind of is there reproductive division of labour in the form of fully distinct castes in the society? Is there a breeder caste and a helper caste? And if the answer to both of those is no, but they still live together and kind of breed together, then you have something called a communal breeder, where everybody is having their own offspring and caring for their own offspring. They're just living together. Things like lions and those prairie dogs. If you have helpers providing care, but they're not physically distinct, you have something which we call a cooperative breeder. We have a whole lecture on cooperative breeding on Friday. Things like meerkats and paper wasps and those ants, the ants where they're not morphologically distinct, the giant ants. Helpers providing care, but no caste. And then, of course, you have eusocial societies where you have a fully distinct helper caste, which is less reproductive than the breeder caste. Things like naked mole rats, most ants, all termites, and those pistol shrimps, and things like bees, etc. Then you can divide societies up by how sociality is achieved. Like you can look at the route that they got to sociality. So you've got offspring helping, like you've got a subsocial route where offspring help their parents. You have a route where sisters collaborate together and one of them becomes dominant. That's like your queenless ants. Then you have a parasocial route where unrelated individuals come together, of which one becomes dominant. And that's more like your social spiders. I'm going to skip through. We've not got that much long left, but I just want to give some examples of different routes to sociality. The subsocial route is exemplified by things like these social cockroaches, where the offspring tend to stick behind because because of some factor which keeps them behind with their parents, like feeding on dead wood. And in cockroaches, you've got this delightful behaviour called proctodial trophallaxis, which is a complicated Latin way of saying the offspring stick their heads up the parents' bums and feed on their poo. And that transfers bacteria that allows them to digest wood as adults. And so that requirement, the whole clade of wood-feeding cockroaches relies on that, and then termites as well, relies on this behaviour. So it puts offspring in very close contact with adults. And you get these really kind of intensive parental behaviours, like Diploptera here makes milk for its offspring. You have a milk-producing cockroach. And very recently, I should have put this in, there's even a milk-producing spider which produces milk for its offspring. So cockroach milk is one thing that I'd like you to take away from this. Bees are another clade which is subsocial. We think about bees as being honeybees, but that's actually one species. There are thousands upon thousands of other species of bees, most of which have a subsocial structure where offspring kind of stick around and help mother produce a nest. A lot of them are solitary with just a parent producing offspring, but a lot of them have this case where offspring stick behind in the nest and help mother produce more offspring. You have semi-social bees where groups of sisters stick together. Some of them can decide whether or not to be social. So you can either be solitary and just a parent with offspring, or the offspring can decide to stick behind. There's a wonderful example of that here in the UK. Not so common bee, but my old prof, Jeremy Field, did this wonderful experiment. So this is Halictus rubicundus. The females decide whether to be social or not. And Jeremy Field showed that they make that decision depending on latitude. We'll come back to that in a sec. So you've got colonies at these 4 places in the UK, southern ones and northern ones. And Jeremy Field took colonies from the north and transplanted them to the south. The northern ones tend to be solitary, and the southern ones tend to be social. And he did a transplant experiment where he transplanted them along from the south to the north, which is transplant B, and from the north to the south, which is transplant C. And he found that the ones which were previously social, if you transplant them to the north, the females decide to be solitary. And if you take the ones that are solitary in the north and transplant them to the south, to Sussex, they decide to be social. And the interpretation he put on that is that in the south there's a longer growing season, and the social ones have a generation of workers which then raise a second generation of reproductives. And the idea is that in the south there's time to do that because there's a longer growing season, whereas in the north there's not enough time to produce that second generation. So there's a really, really nice study there, Field et al. 2010 is a beautiful example of facultative social behaviour, a behaviour which is kind of exemplifies the kind of early ancestral origins of social behaviour.